Today we'll talk about the square root property. We're going to solve quadratic equations using square roots. In step 1, we need to isolate the second degree term on one side of the equation. We'll use the multiplication property of equality to get a coefficient of 1 for the second degree term. So if we are not starting with x squared, we have to do something to eliminate the coefficient. For example, if we had 3x squared for the first term, to eliminate 3, every term would need to be divided by 3. So I'll show you how that works in a later example. Step 3, we're going to take the square root of each side of the equation. Once we take the square root of each side of the equation, we need to consider both the positive and negative square root solutions. In our first example, we have x squared equals 196. We can see that the coefficient of x squared is positive 1, so we're ready to take the square root of each side of this equation. That would give us the square root of x squared equals the square root of 196. Well, I can see that square rooting a perfect square will undo those operations, they're opposite operations, and I'll have x equals my answer. But I'm wondering if 196 could be broken down into some other factors that are a perfect square. So the first thing you could try on your calculator is to enter 196 and use your square root function. Once you do that, you'll see the answer is 14. But one thing that we need to consider is the positive square root and the negative square root. So it's not just 14, it's positive 14 and negative 14. We actually have two solutions, x equals 14 and x equals negative 14. So don't forget to take the positive and the negative square root. If you don't have a calculator handy, what you could do is take the 196 and use your factor ladder. 196 is an even number, so I could divide by 2 to get 98. I could divide that by 2 to get 49. I could divide 49 by 7 to get 7, and divide 7 by 7 to get 1. So I have a pair of 2's, which make 4, and a pair of 7's that make 49. So I really have the square root of 4 and the square root of 49. So that means plus or minus the square root of 4 times the square root of 49. So I know 4 would be released as 2. 49 would release as 7. And 2 times 7 makes 14. So that's just another way to get the same answer if you don't have your calculator. With example 2, I have x squared minus 64 equals 0. So our intention here is to use the square root property. In order to do that, I need to isolate my second degree term on one side of the equation. So I'll need to start by adding 64 to both sides of this equation. So now x squared equals 64. And I'm ready to use my square root property. Take the square root of each side. Don't forget it's plus or minus square root. So the plus or minus square root of 64 is going to be plus or minus 8, because the square root of 64 is 8. With example 3, I have 4x squared equals 45. Well, notice this time that we have a coefficient in front of x other than positive 1. So I need to divide both sides of this equation by 4 to isolate x squared equals something. 45 doesn't divide evenly by 4. So I'm going to leave the fraction as 45 over 4. Our next step is to take the square root of each side of the equation. Don't forget it's plus or minus the square root. Well, this is where the quotient rule is going to be helpful, because we can break apart this single fraction under the radical as plus or minus square root 45 divided by square root of 4. Now we know that the square root of 4 is 2. So I'm going to simplify that denominator of the fraction as 2. But we need to work with 45. So you could use your factor ladder again, starting with 45. Since it ends with 5, I could divide by 5 to get 9. 9 is divisible by 3. That leaves me 3. 3 is divisible by 3, leaving 1. So the factors of 45 are 5 and 9. So we're looking at the square root of those numbers. So we would have square root 9, square root 5. 9, however, is a perfect square. That's the same as 3 square roots of 5. So the final answer would be plus or minus 3 square roots of 5, all divided by 2. And our final example, 25x squared is equal to 48. Again, we notice that we have a coefficient other than positive 1 for our second degree term. So I'll divide both sides by 25, and that gives me x squared now equals the fraction of 48/25. Taking the square root of each side, remember it's plus or minus, I'll use that quotient rule again. So square root of 48 is divided by the square root of 25. In the denominator, I know the square root of 25 is 5. So it's just this numerator we're going to have to work with a little bit. So starting with 48, since it's even, I'll divide by 2 to get 24. I'll divide by 2 again to get 12. Divide by 2 to get 6. Divide by 2 to get 3. And finally divide by 3 to get 1. So it looks like I have a perfect square of 4, another perfect square of 4, and then a factor of 3 by itself. I notice I've got another set of 4. So really that would be square root 16, square root of 3. Square root of 16 we know is 4. So 4 square roots of 3. And don't forget it's plus or minus